got 2 moon rises that we've had so far, and the views of planet Earth, we forgot how beautiful it is to look down on Earth. Humanity has once again shown what we are capable of.
There is a number that should bother you more than it probably does. 196,940 miles. That is the distance between the surface of the moon and the point where the Earth's gravity fully takes over. Cross that line in a spacecraft, and you belong to the moon. It owns your trajectory. The only way back is the engine behind you, and if that engine fails, there is no rescue, no second option. Just the slow arc of physics doing exactly what physics always does. For 50 years, we looked at the moon and decided we had done enough. 6 landings, a handful of rover tracks, a few hundred kilograms of rock sealed in storage at Johnson Space Center. We wrote the textbooks, drew the diagrams, and somewhere along the way we quietly agreed that the moon was a solved problem, a stepping stone, a thing we had already been to. Then, on April 6, 2026, 4 astronauts came within 4,000 miles of its surface, swung around the side that has never once faced the Earth, and what one of them transmitted back to mission control before the signal cut out was not a scientific observation. It was closer to bewilderment. He said, in plain words, that he did not believe human beings had evolved far enough to understand what they were looking at. That is not something astronauts say. Astronauts are selected, in part, because they do not say things like that. They are trained to describe, quantify, report. The vocabulary of spaceflight is precise almost to the point of being cold. So when a Navy test pilot with over 160 days in orbit reaches for language and comes back empty-handed, you have to ask yourself what was actually out there. This is that story. And to tell it properly, we have to start not with the moon, but with the silence, the day it all changed. On April 1st, 2026, at 6:35 in the evening, Launch Pad 39B at Kennedy Space Center in Florida lit up for the first time in years. The Space Launch System, NASA's most powerful rocket, standing 322 feet tall, produced 8.8 million pounds of thrust at liftoff. That number means very little until you know what it is being compared against. It exceeds the Saturn V, the same rocket that put humans on the moon during Apollo, the same one engineers spent decades calling unbeatable. 6 minutes after ignition, the crew of Artemis II was in orbit. 11 minutes after that, a second engine burn fired and broke them free of Earth entirely. That burn is the one that matters. Before it, the mission is still recoverable, still adjustable. After it, the trajectory is locked. Physics takes over. The moon is no longer a destination. It is an inevitability. The 4 people aboard that spacecraft were Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen. Together, they carried a weight that went far beyond altitude or distance. Victor Glover became the first black astronaut to travel beyond Earth orbit. Christina Koch became the first woman to do it. Jeremy Hansen became the first non-American to travel to deep space, and all 4 of them were doing something no living human being had done since December 1972, flying toward the moon. They named their spacecraft Integrity. That name would earn its meaning before the mission ended. 5 days after launch, Integrity reached the moon. The crew began a 7-hour flyby observation period, sweeping past at roughly 4,067 miles above the surface. And as they swung around the far side, the half of the moon that permanently faces away from Earth, the half no human being had ever observed directly at close range, Victor Glover tried to describe what he was seeing before communications cut out entirely. He could not find words that fit. What he did manage to transmit was that it was beyond what human beings had evolved to comprehend, that it was otherworldly, that it was, in the truest sense of the word, amazing. 2 weeks later, at a press conference at Johnson Space Center in Houston, Commander Wiseman stood in front of a crowd and said that no one on Earth was ever going to truly know what the 4 of them had been through, that it was the most significant thing that would ever happen in his life. Victor Glover told that same crowd his gratitude was too large to fit inside one body. Christina Koch said the mission had taught her what it actually means to be part of a crew. Jeremy Hansen looked straight at the audience and told them to stop staring at the astronauts. The crew, he said, was a mirror. What they were seeing reflected back was not 4 people. It was everything humanity could accomplish when it decided to reach. Those are not the words of a routine orbital test. They are the words of people who saw something that changed them permanently. And understanding what that something was requires us to talk honestly about what the moon actually looks like on the side it has never shown us: the burn and the blackout. There is a specific type of silence that cannot exist anywhere on Earth. It requires a mass of 2,160 miles of solid rock positioned precisely between you and every radio transmitter your species has ever built. It requires that mass to block every frequency simultaneously. No voice, no data stream, no abort command from the ground, no way for anyone who loves you to reach you. For 40 minutes, with the moon standing between them and the rest of humanity, the crew of Integrity were completely and unreachably alone. At 6:44 in the evening on April 6th, as the spacecraft swept behind the moon and began its arc over the far side, every communications link with Earth cut simultaneously. This was expected. It was planned. It was still, by every account from the crew, one of the most profound things any of them had ever experienced. What the crew chose to do in those first minutes says something about who they were. Before the blackout hit, Jeremy Hansen had quietly packed a small supply of Canadian maple cream cookies for exactly this moment. When the signal dropped, and the four of them were finally, genuinely alone, they gathered together and shared them. It was a small and deliberate ritual, a way of marking a moment no one else on Earth could witness alongside them. Meanwhile, the spacecraft continued its arc at approximately 60,000 miles per hour. 2 minutes after closest approach, Integrity reached 252,756 miles from Earth. The four people aboard it became the most distant human beings in the entire history of our species. They surpassed by more than 4,000 miles the previous record, held by the crew of Apollo 13 in 1970. There is a critical difference between these two records. The Apollo 13 crew reached that distance because their spacecraft was crippled, and they had absolutely no choice. The Artemis 2 crew went there on purpose. At 7:25 in the evening, the Deep Space Network reacquired the signal from Integrity. Mission control erupted. Christina Koch's first transmitted words back to Earth were simple and immediate. "It is so great to hear your voices again." The 10 days the crew spent inside that spacecraft were not abstract. The vehicle was 16.5 feet wide, roughly the footprint of a large camper van shared between four people. The toilet broke early. Sleep happened in microgravity. Video calls to family crossed a delay long enough to make every conversation feel like reaching across a canyon in slow motion. Wiseman later said that one of the most affecting moments of the entire mission was listening to his crewmates on those calls, hearing them giggle and cry and catch their breath, and love the people they had left behind from 250,000 miles away. The far side waiting on the other end of that blackout is so different from the moon we see each night that planetary scientists still argue about how the same object could have formed two completely opposite landscapes on either side of itself. To understand what the crew actually saw, you need to understand how extreme that difference is. Two faces, one object. The moon you know is only half of the moon that exists. The near side, the hemisphere that has faced Earth without interruption for billions of years because of a phenomenon called tidal locking, is covered in wide, dark plains called Maria. In Latin, the word means seas. Ancient astronomers named them that because they looked like water from the ground. They are not water. They are ancient lava, massive flows that poured into enormous impact craters billions of years ago, cooled over millions of years, and left behind the flat, dark basalt floors that give the moon its familiar, recognizable face. About 31% of the near side is covered by these volcanic plains. The far side has almost none of them, less than 1%. Instead, it is craters, on top of craters, on top of older craters. Still, 4 billion years of constant bombardment with almost nothing ever smoothed, filled, or erased. It does not look like the same object. It looks like a completely different world that happens to be gravitationally attached to the first one. When Jeremy Hansen first caught it through the windows of Integrity, the word he reached for was moonjoy, not a term from any scientific vocabulary, something he coined on the spot because nothing else fit. He also radioed to Mission Control that what surprised him most was the sheer three-dimensionality of it. From Earth, the moon is a flat disk, a coin in the sky. From 4,000 miles above its surface, it becomes unmistakably a sphere, its curvature enormous and obvious, tilted at angles no one on the ground has ever seen. The crust on the far side is approximately 50 kilometers thicker than on the near side. No single theory fully explains why. The leading explanation involves a second catastrophic impact near the Moon's south pole in the early solar system, something so violent that it drove heat-producing radioactive elements toward the near side. That surge of heat produced the volcanic flooding that smoothed everything we see when we look up at night. The far side, meanwhile, stayed thick, cold, and untouched by anything except the endless rain of rocks falling out of space across billions of years. That original catastrophe left behind the South Pole Aitken Basin, the largest preserved impact crater in the entire solar system, 2,500 kilometers across, 13 kilometers deep. Laid over a map of the United States, it would swallow everything from Texas to Virginia. Its rim mountains reach 8,500 meters, comparable to the highest peaks of the Himalayas. Every piece of data we had on this structure before April 6, 2026 came from robotic instruments. The Artemis II crew became the first human beings to observe its eastern edge directly. NASA deliberately designed the flyby path to expose roughly 21% of the far side to direct sunlight from the crew's perspective, specifically targeting features no astronaut had ever seen firsthand. Among the science targets were the Orientala Basin, a 600-mile-wide impact scar 3.8 billion years old sitting at the boundary of the near and far sides, and the Hertzsprung Basin, a 400-mile-wide crater whose features have been worn down by subsequent bombardment. Scientists in the Science Evaluation Room in Houston were using the contrast between the two to build a real-time geological timeline: fresh versus ancient, sharp geometry versus eroded structure. The crew's eyes were their primary instrument. Before reaching the far side, the crew also photographed Reiner Gamma, a bright, swirling pattern on the near side that looks like someone dragged a white paintbrush across dark rock. It has no physical height. It is not a crater or a lava deposit. It is a flat optical feature sitting in perfect alignment with a localized magnetic anomaly in the crust directly beneath it. The Moon lost its global magnetic field billions of years ago, yet these ghost signatures persist in scattered patches across the crust like traces of a force that no longer exists. Whether that magnetism is actively shielding the surface from solar wind weathering, which slowly darkens rock over geological time, or whether something else entirely is producing the brightness, nobody knows. The things buried underneath. Here is where the Moon stops being a familiar object and starts being something stranger. Not strange in a dramatic science fiction sense. Strange in the way that a solid, well-understood theory suddenly develops a crack, and you can see light on the other side of it. There are three things buried beneath the far side that individually would be remarkable. Together, they suggest we have been working from an incomplete picture of what the Moon actually is. The first is the mass anomaly. In 2019, planetary geophysicist Peter James at Baylor University combined two datasets that had never been analyzed together. Gravity measurements from NASA's Grail mission, in which two spacecraft spent months mapping minute variations in the Moon's gravitational field, and topographic data from the Lunar Reconnaissance Orbiter. What emerged was a blob of extraordinarily dense material sitting at least 300 kilometers beneath the floor of the South Pole Aitken Basin. Its minimum mass, 2.18 quintillion kilograms. James put that number into human terms this way: it is roughly equivalent to burying a pile of metal 5 times the size of the big island of Hawaii underground. Its gravitational pull measurably drags the basin floor above it downward by more than half a mile. The most credible explanation is that this is the metallic core of the asteroid that created the basin in the first place. When the impactor struck at a shallow angle, its iron and nickel core survived the collision partially intact instead of vaporizing completely, sank into the lunar mantle, and never came back out. 4 billion years later, it is still there. Embedded like a bullet fragment, the body never expelled, quietly pulling the ground above it downward. What is unsettling about this is not that it exists, it is that we only found it in 2019. The second anomaly is, in some ways, harder to explain. In 2023, researchers detected a thermal signature beneath the far side, a region approximately 50 kilometers wide that was registering roughly 10 degrees Celsius, warmer than everything surrounding it. The source is almost certainly a buried block of granite. This is a problem because granite requires two things to form: water and plate tectonics. The Moon has neither. It has never had either. Yet beneath the far side, there is a granite body believed to be the remnant core of a volcanic system that went quiet 3.5 billion years ago, its internal heat still slowly bleeding into the rock surrounding it. The lead scientist on that study, Matt Siegler, noted publicly that the finding looks far more like something you would expect on Earth than on the Moon, and then asked the question nobody had anticipated needing to ask: what else is still warm down there? The third buried secret is perhaps the most practically significant, depending on where humanity goes next. Radar data and orbital imaging have revealed what appear to be extensive underground tunnel networks across the Moon, formed when ancient lava flows drained and left hollow tubes behind. On Earth, lava tubes can reach tens of meters across. On the Moon, where gravity is 1/6 as strong and ancient flows ran at far larger scales, some of these tubes may be vast enough to shelter entire research stations. Their entrance pits are visible from orbit. What is inside them, whether trapped gases, mineral deposits, preserved ice in permanently shadowed sections, is entirely unknown. They have been sealed for billions of years. They are waiting. Beneath the floor of the South Pole Aitken Basin, something with the mass of 5 Hawaiian islands has been sitting in the lunar mantle for 4 billion years. It warps the gravitational field above it. We have no way to retrieve it, image it directly, or fully explain it. And it is just one of 3 things under that surface that have no clean explanation. Now consider that everything we knew about the Moon before this mission came from instruments, and that the crew's eyes, during 7 hours of observation, caught things no instrument did, what only human eyes could catch. A reasonable question to ask at this point is why human observers were necessary at all. We have orbiters, we have rovers, we have decades of satellite imagery, and 4 generations of robotic instruments. What does a person looking through a window 4,000 miles up add that a camera cannot? NASA's pre-mission answer was precise. Human eyes and the pattern recognition systems behind them detect simultaneous variations in color, texture, depth, and luminosity in ways that no robotic sensor currently replicates. The brain draws on a lifetime of visual experience to flag anomalies that an algorithm cannot anticipate, because the algorithm only knows what it has been taught to find. The Artemis II crew trained for months in Iceland and other volcanic terrains specifically to identify and describe geological features rapidly under observation conditions. The Orion capsule carries more shielding than any spacecraft that flew during Apollo, but galactic cosmic rays, particles accelerated by supernova explosions in distant parts of the galaxy, travel at near the speed of light and pass through virtually everything humans have ever built. There is no practical shield against them today. Apollo astronauts reported seeing streaks of light behind their closed eyelids during their missions, high-energy particles passing directly through their retinas. Several of them developed cataracts at statistically unusual rates in the years that followed. The Artemis II mission carried an experiment designed to begin changing what we understand about this threat. Called AVATAR, Virtual Astronaut Tissue Analog Response, it was developed at Harvard's Weiss Institute. Researchers grew miniature replicas of each astronaut's bone marrow inside chip devices the size of a USB thumb drive, using cells drawn from the crew's own pre-flight blood donations. One set of these chips flew with integrity for the full 10 days. An identical set stayed on Earth as a control. Post-mission, scientists are now sequencing the returned chips at the single-cell level, measuring how thousands of individual genes shifted inside living human tissue during 10 days of deep space radiation exposure. Wyss Institute Director Donald Ingber said the goal was to study these risks in a personalized way that had never before been possible, with the aim of eventually building radiation countermeasures tailored to individual astronauts going on individual missions. The same technology, he noted, could improve cancer radiation therapy on Earth. When Earth reappeared on the crew's displays after the blackout lifted and the eclipse ended, the crew transmitted an image that mirrored one of the most recognizable photographs in human history. Except in this version, the Earth was not rising. It was disappearing. What the far side has been telling us all along. At 6:41 in the evening on April 6th, minutes before communications cut out completely, Christina Koch watched Earth slip behind the lunar horizon through the window of integrity. NASA named the resulting photograph EarthSat. It mirrors Earthrise, the image captured by Apollo 8 astronaut Bill Anders on Christmas Eve of 1968, in which the Earth appears above the lunar horizon, vivid and blue, and unmistakably present. In Earthrise, Earth was arriving into view. In Earthset, it is leaving. Koch said afterward that the moment lasted only a second or two, but that something pulled her suddenly into the lunar landscape, and it became real to her in a way it had not been before. She said, "The moon is its own body in the universe, not a prop, not a backdrop, not a poster in the sky we glance at and dismiss. When you find yourself on the other side of it," she said, "it reminds you that everything we need the Earth provides, and that you cannot genuinely understand that until you have had the perspective of standing somewhere Earth cannot follow you." The crew named 2 craters during the flyby. The first they called Integrity, after the spacecraft. The second they named Carol, after Commander Wiseman's late wife, Carol Taylor Wiseman, who died in 2020. Carol Crater sits at the exact boundary between the near and far sides of the Moon. With a strong enough telescope and precise enough coordinates, it is visible from Earth. It will carry that name permanently. The far side is already the focus of active science from other nations. China's Chang'e 4 lander touched down inside Von Karman crater in January 2019, the first soft landing on the far side in the history of spaceflight, requiring a dedicated relay satellite called Queqiao, positioned in a halo orbit beyond the Moon just to maintain radio contact. The Yutu-2 rover found olivine and pyroxene in the surface material, minerals from the lunar mantle, confirming that the South Pole Aitken impact had excavated material from hundreds of kilometers below the surface. In 2024, Chang'e 6 collected physical samples from the far side and returned them to Earth, the first material from the Moon's hidden hemisphere ever brought to a laboratory. Researchers were still working through those samples during the Artemis 2 flyby. The far side also offers something no other location in the inner solar system can provide: permanent shielding from the electromagnetic noise of human civilization. Every cell tower, broadcast antenna, satellite uplink, and Wi-Fi router on Earth is blocked by 3,400 kilometers of solid rock. Earth's ionosphere further blocks all radio frequencies below approximately 30 megahertz, cutting off an entire band of cosmic signals that has never been detected from anywhere on or near our planet. Telescopes on the far side of the Moon could hear those frequencies for the first time, including signals from the period of recombination, when the first hydrogen atoms formed after the Big Bang and emitted radio waves that have been traveling through space ever since, waiting for a receiver that is not buried beneath an atmosphere. NASA and the European Space Agency have already proposed observatory designs for exactly this location. Now, take everything we have covered and lay it out together. The mass anomaly 300 kilometers below the basin floor that warps the gravitational field above it. The granite body that had no right to form on a world without water or tectonics, still bleeding heat into surrounding rock. The 2 hemispheres that no single model fully explains. The ghost magnetic signatures in a crust that lost its global field billions of years ago. The moonquakes that Apollo seismometers detected in what we had declared a geologically dead world. The sealed lava tubes large enough to shelter entire research stations never opened. The 6 impact flashes that 54 minutes of eclipse revealed, and that only human eyes were fast enough to register. We built our entire model of the Moon from 6 landing sites. Every single one of them was on the near side. Every single one was chosen for safety and accessibility, not scientific diversity. The equivalent, as one scientist put it, of landing in the Sahara and concluding that the entire Earth is made of sand. What comes after the questions? The crew of Artemis 2 splashed down on April 10, 2026, in the Pacific Ocean off San Diego, after 694,000 miles. During the flyby, they rotated in pairs at the windows, working with telephoto lenses, narrating what they saw to mission control in real time. Scientists in the science evaluation room updated the observation plan continuously and uplinked new guidance to the crew throughout all 7 hours. Christina Koch reported that smaller, more recent impact craters appeared dramatically brighter than the ancient terrain surrounding them. She described them as pinprick holes in a lampshade glowing white against gray. The contrast is not just visually striking, it is scientifically useful. Fresh craters punch through the space-weathered regolith that billions of years of solar wind exposure have slowly darkened, exposing pristine material from below. Brightness equals geological youth. Darkness equals age. The entire surface is a map of time written in light, and the crew was reading it directly, in real time, relaying what they saw to researchers who had spent careers trying to extract the same information from processed satellite data. Victor Glover became absorbed by what geologists call the terminator, the boundary line where lunar day meets lunar night. Along that line, sunlight arrives at extreme grazing angles, throwing shadows kilometers across flat ground and converting every ridge and crater rim into a sharp, dramatic silhouette. Crater floors that appear nearly level under full illumination become ink-black voids along the terminator. Glover radioed to Houston that it was full of magic, that the islands of light and valleys of shadow looked like holes a person could fall straight through to the center of the moon. That is a trained test pilot describing something as magic. That does not happen often. The crew also observed color variations in the surface that orbital cameras had consistently compressed into uniform gray. Browns and greens on the near side, subtle blue tints in specific regions. These shifts carry mineralogical information, revealing composition and relative age in ways that require elaborate computational processing to extract from a camera image, but that a trained human eye reads almost instantaneously. The Science Evaluation Room received these reports, according to NASA, with grins, nods, and, in their words, a lot of chatter. Wiseman said at the press conference that if Integrity had been carrying a lunar lander, at least 3 of his crewmates would have been scrambling to climb into it the moment they saw the surface up close. A Navy commander, a veteran astronaut, telling you what direct sight of the moon does to a person who has spent their career training to explore it. Then, the sun moved, and the far side went dark, and something happened that no camera on the spacecraft was fast enough to record. The eclipse and what it cost them. As the 7-hour observation window neared its end, the spacecraft, the moon, and the sun aligned perfectly. The moon swallowed the sun whole, totality. From Earth, the longest total solar eclipse a person can witness from the ground lasts roughly 7.5 minutes, and only if you are standing at exactly the right latitude and longitude at exactly the right time. The Artemis II crew had 54 uninterrupted minutes of totality, from a few thousand miles above the lunar surface, where the moon appears 5 times larger in the sky than the sun does. No human being had ever experienced an eclipse anything like it. The solar corona, the sun's outer atmosphere, ordinarily invisible against the daytime sky, flared outward around the entire rim of the moon in a continuous glowing halo. Victor Glover transmitted immediately after the sun disappeared. "You can see the Earth shine. Earth is so bright out there." Stars that are normally too faint to image against a bright lunar backdrop became visible. Venus, Mars, Saturn, and Mercury were all in Integrity's line of sight simultaneously, and the crew photographed all of them. Scientists studying the imagery afterward were attempting to determine whether the glowing halo was purely corona, or whether zodiacal light from interplanetary dust was also contributing. Kelsey Young, the mission's lunar science lead at NASA's Goddard Space Flight Center, described it as a truly unique vantage point that no instrument had ever been positioned to capture before. The crew had been trained before the mission to watch for meteoroid impact flashes during the totality period, brief bursts of light from small rocks striking the unprotected lunar surface at tens of thousands of miles per hour. These flashes last milliseconds. They are almost impossible to photograph without extraordinary preparation and a fair amount of luck. Nobody genuinely expected the crew to see any. They saw 6. Wiseman reported in real time. That was definitely impact flashes on the moon, and Jeremy just saw another one. When Kelsey Young asked about color and duration, Wiseman said each flash lasted approximately 1 millisecond, the fastest a mechanical camera shutter opens and closes, and appeared white to bluish white. Hansen described each one as a pinprick of light, gone before the eye could fully register it. Young later said the response in the Science Evaluation Room was audible screaming, that she probably had not expected the crew to see any at all. Not one camera aboard the spacecraft captured a single frame of any of the 6 flashes. The shutters were too slow. Only human eyes, which process incoming light continuously rather than in discrete mechanical exposures, were fast enough to catch them. Peter Schultz, Professor Emeritus of Geological Sciences at Brown University, commented afterward that the rate of impact strikes observed during just a few hours suggested the daily meteoroid impact rate on the moon required far more careful monitoring before any permanent human base was established there. Ground teams immediately began cross-referencing the crew's reports with satellite data and contacted amateur astronomers who had been observing the moon from Earth at the same moment. While all of this was happening outside the windows, something invisible was happening to the crew's bodies that scientists consider the single greatest obstacle to long-duration human space exploration. The Artemis 2 mission launched during solar maximum, the peak of the Sun's 11-year activity cycle, when the rate and intensity of solar particle events is at its highest. During a severe event, radiation doses inside a spacecraft can climb toward dangerous levels within hours. The Avatar bone marrow chips are being sequenced, the flyby photographs are being processed, the meteoroid impact data is being cross-referenced with satellite records and reports from amateur astronomers around the world. And Artemis 3, the mission that will land humans on the moon for the first time since 1972, is being directly shaped by what Wiseman, Glover, Koch, and Hansen saw, heard, and reported during 7 hours over a surface that had been waiting for human eyes since before our species existed. The far side does not just contain things we did not expect. It contains things that force every fundamental assumption about how moons form, cool, and evolve to be reconsidered from the beginning. Every answer the data gives opens 3 more questions, and the questions keep getting harder rather than easier. The next missions are not flying past. They are landing on a surface whose geology we do not fully understand, beneath a radiation environment we cannot yet fully shield against, above lava tubes we have never entered, near a gravitational anomaly that has sat in the mantle, undisturbed, for 4 billion years. We spent decades looking at half a moon and calling it understood. We wrote the books, we gave the lectures, we put the photographs on the walls of school classrooms and answered the children's questions with confidence. Then 4 people swung around the back of it, and within minutes one of them was transmitting that human beings had not yet evolved to the point of comprehending what they were looking at. The moon is not a solved problem. It is a question that has been sitting in the sky for 4 billion years, waiting for us to ask it properly. We have just barely started. If that sits differently with you now than it did at the beginning of this video, drop a comment below. Tell me which part changed something. And if you want to go deeper on any of it, the mass anomaly, the lava tubes, what the Avatar results actually showed, those are the next videos. They are already waiting.